So our next section is 11.3, which is the expected value. You can also think of this as expectation. So when you're trying to calculate a risk of something, you want to know what your expected value is, or just expectation for short. So it's used to determine what you expect the results will be of an experiment or a business venture over a long term. So maybe you want to invest some type of money and there's a risk associated to it. Well, if I input $1,000, how much am I expected to make? Am I expected to make 50 off of it? Am I expected to make 10,000? Am I expected to lose money? We want to know what that specific outcome is potentially going to be to give us a good idea if it's worth doing this. So let's think of a simpler example. I'm going to make a bet with you. We're going to roll a die, say 1,000,000 times. If it's even, then I'm going to give you $1. If it's odd, you're going to give me that $1 back. And we're just going to keep doing this over and over and over and over. So we want to figure out who would win money in the long term. Will you win money? Will I win money? Are we going to break even? So if you think of these two events, we're doing even and odd. We're splitting the outcomes on the die right down the middle. So half the time, I would expect you to pay me $1 from rolling an even, because half the time it would roll even. The other half, I would expect you to pay me $1 because the other half of the time, it's odd. Okay. So overall, I expect that we're just going to break even from this game. So why would that actually happen? How can we see that exactly? So my expected gain and loss could be broken down into a few things. We've got the probability I win, and let's see how much we'll gain from that. And let's add the probability that I lose times the amount I'm going to lose. So rolling an even is a 3 in 6 chance. So half the time, I'm going to roll an even number, and with that, I'm going to gain $1. Half the time, I'm going to roll odd, and I'm going to net negative $1. So you're going to get positive a half minus a half. In the end, you're going to make no money. So that's exactly what this expected value is. You're going to look at all of your possible outcomes, and you're going to see what's the probability of this outcome, and what do I gain or what do I lose. So is it a positive amount or is it a negative amount? So the way you can think of this is you're going to take some probabilities. So this one here is going to be the probability event 1 occurs. And A1 is going to be the net amount you win, or in the case you lose, it would be negative if event 1 occurs. And you're going to do this for however many events there are. So you could have this first event, maybe you have a second event, a third event, a fourth event, all the way up to however many events there possibly are. So there could be, 100 different events. You have 100 different probabilities you have to calculate along with those net gains or losses. So let's think of a business venture. Stephanie estimates there's a 60% chance she'll make $80,000 and a 40% chance she's going to lose $20,000. So we want to see, is this going to be a smart move for Stephanie? Should she go in this business venture? So if she has an expected value that's positive, it's good for her. But if her expected value is negative, not a good chance. So we could gain $80,000 or we could lose $80,000, but they're weighted a little bit differently. So we need to calculate our expected value, which is E. So we've got 2 events that are going to occur. The first one is the probability that she's going to make some money. and we want to look at the money she makes. So this is the amount she's going to gain. The second event that it could occur is she could lose money. So this would be the probability of losing times the amount she loses. Right? So she has a 60% chance that she's going to make money. So as a probability, that's 0.6. Okay? So this is the 60% chance from right here. Okay. And what she's going to make is $80,000. Then we want to add to that the probability she loses. So there's a 40% chance, which you can turn into a decimal as 0.4. So this is our 40% chance for event 2. And the amount she's going to lose is $20,000. So we want to indicate that it's a negative value to indicate it's a loss. So you have to make sure that you put this minus when it's a loss. Right? So if we take 0.6 and we times it by 80,000, you plug that into your calculator, she would make 48,000. And then 0.4 times negative 20,000 is 8,000. So our expected value is $40,000. Okay? So if she goes in this business venture, she's going to expect that she's going to make $40,000. So this would be a good decision or good business venture. If she had gotten something negative as her expected value, then that's going to indicate that she probably shouldn't make this deal because she's going to lose out on it in the long run. Okay? So let's try some more examples. At the Royal Dragon Chinese restaurant, you get a slip and a fortune cookie that will subtract some type of money from your bill. So there's going to be a bag of 10 fortune cookies, and you're going to pick one of those at random. So 7 of the fortune cookies contain $1 off your bill. 2 fortune cookies are $2 off your bill. And 1 fortune cookie, you get $5 off your bill. So we want to see what our expected value is. So how much can we expect will come off of our bill? So we have 3 different scenarios. So our expected value is going to be the sum of 3 things. The first event is the probability of getting $1 off. And then our amount we're going to get off is exactly $1. Our second event is we get $2 off. And then our gain from that is you're going to make $2 because you don't have to pay it. Then finally, we want the probability of getting $5 off. And then we're going to net $5 because we don't have to spend that anymore. So in total, we have 7, 2, and 1, or in total, there are 10 fortune cookies. So our probability of having $1 off is there are 7 out of 10 fortune cookies that have a $1 off. And then you times this by a 1. And then $2 off, there are 2 fortune cookies out of 10 that net you $2. And finally, for $5 off, there's 1 fortune cookie out of 10 that will net you $5. Okay? So this is our first case, our second case, and our third case, our 3 different events. So if we take the 7/10 and times it by $1, that's going to be 70 cents. If you take the 2/10 and times it by $2, you're going to see that's 40 cents. And then the 1/10 times $5 would be 50 cents. So we're going to expect, by pulling a fortune cookie off, in the long run, we would get $1.60 off of our bill. Okay? All right. So what we want to get to is, if you've ever been to some type of charity event before, or sporting events, they often do a lot of raffles. So in our next example, we're going to be working with a raffle. There are going to be 2,000 raffle tickets that are sold, and each one is going to be $3 per ticket. So we want to see what's our possible expected outcome. 3 prizes in total are going to be awarded. 1 person will get $1,000. 2 people will get $500. We're going to purchase a single ticket for $3, and we're going to see what is our expected value. So we need to see first, what are these possible events, and what are the probabilities associated to them. So our first event is you could win $1,000. So 1 person in total will win $1,000. So your probability of winning $1,000 is 1/2,000. The rest of that will pop up in a second. Probability of winning $500 is going to be 2 out of 2,000. So 2 people will win $500. So that'll reduce nicely to 1/1,000. The third possibility is you don't win or lose. You don't win, so really you're going to lose $3 on that ticket. So the probability of losing is everyone remaining. So there are 3 winners, which means there's 1,997 losers. So for our expected value, we want to look at the probability of these events times what you're actually going to gain from it. Okay? So let's go through this together. Our expected value is going to be our first event, so the probability of getting $1,000. And the net amount for this person is really only going to be $997 because you input that initial 3. Then the next event is your probability of winning $500, and you're going to win $500, but you've put in $3, so you're only going to net $497. Then our third event is your probability of you lose, so your ticket doesn't get called, and you're losing $3, so it's -3 as your loss. Okay. So we've calculated our probabilities already. The probability of winning $1,000 is 1/2,000, and then you're going to net $997. The probability of getting $500 is 1/1,000, and you're going to net $497. The probability of losing is 1,997 over 2,000 times -3. Okay? So if we go through and do this, we're going to have to round because it is talking about money. If you take the 997 and divide it by 2,000, you get 0.4985. So we're going to round it to the nearest penny. that's 50 cents. Now if you take 497 and divide it by 1,000, you're going to get 0.497. So again, 50 cents. And then the 1,997 divided by 2,000 times -3 will end up giving you -3 when you round to the nearest penny. So our expected value is -2. So what that means is we expect to lose $2. Okay. So be careful when you have to consider this venture you're going in, because that's going to make a difference in these total net gains. So what we want to do is from this figure out what is a fair price to pay for the ticket, so that instead of being expected to lose $2, we're going to make the expectation $0 for everyone. Let's think maybe we pay $1 per ticket. All that's going to do is going to change these values, the 997, the 497, and the $3. So your expected value would be the probability of you winning the 1,000, which is still 1/2,000, and now your net gain is going to be $999. Then the probability you win 500 is 1/1,000, but you're only going to win 499. You still have the same probability of losing, 1,997 out of the 2,000, but now you're only going to lose $1, so -1. Right. So if you go through this with rounding, this would be about 50 cents, that would be about 50 cents, and then rounding, that would be $1. So this would make our expected value exactly 0. Now you're not going to be able to pull a number out of thin air. You don't want to go through just guessing, trying. So there is a nice way to figure out what a fair price is to guarantee that the expectation is going to be 0. So your fair price is going to be the expected value plus the cost you're going to pay for that specific ticket. So if we're told the expected value of a carnival game is $4.50, so that's exactly this expected value, and the cost to play the game is $10. Then our fair price is going to be the expected value, which is -450, plus the cost to play. So a fair price for the game would be $5.50. So the $10 is the cost to play, and that is our expected value. Okay? All right. So let's do one more example with this. We're going to spin this wheel that looks like this. We've got a couple different outcomes. So this sliver here is worth $1, we win. This sliver is $2, and everything's broken evenly. This chunk is $5, and then we could win $10 if we land here or if we land here. So you're going to spend $2 to play this game, and we're going to figure out what our expected value is, and then we're going to also see what a fair price would be. So we need, if you kind of look at each of these, we'll do this off to the side, we need the probability that you're going to land on $1, the probability you're going to land on $5, and the probability you're going to land on $10. Okay? So really this thing is broken down into 8 slices that are nice, cut it right down there, cut it right down here. So you could see a little bit better each of the pieces. So 3 of the slices are orange. So there's a 3 in 8 chance you're going to win $1. Then if we look at the $5, there's a 2 in 8, or really a quarter chance that you're going to win $5. So this is our green. And then finally, there's a 3 in 8 chance you're going to win $10. So this is our purple sections. So if we want the expected value, we need the probability of you getting $1. But what you're actually going to make, because it costs you $2 to play the game, is you're out $1 if you land here. And then we have the probability of you landing $5. And again, you're not winning $5, you're really winning $3 because you spent $2 to play the game. And then we've got the probability of you winning $10, and the net profit will be 8 because you have to subtract the $2 to play the game. So each of these is you have to subtract the $2 to play. So remember, the expected value, those are your net gains or losses, right? But now we've got each of these probabilities. So the probability we get $1 is 3 out of 8, and we're going to times that by -1. The probability of $5 is 1/4, and we times that by 3. Probability of $10 is 3 out of 10, and we're going to times that, or 3 out of 8, and we're going to times that by 10. Okay? So if you plug this into a calculator and round, you're going to see this is about $3.38. So by paying $2 to spin this wheel, we're going to expect that we're going to gain $3.38 if we continue this process over and over and over again. So this is our expected value. Our cost to play the game is $2. So if we want to do the fair price, we're just going to add these two together. The fair price is the cost to pay plus the expected value. So really, this person shouldn't be charging $2. They should be charging $5.38. So this way, in the long run, we're going to expect that we're going to lose 0 instead.